All right, guys, we are back with the second part of this particular lesson where we are solving exponential equations using logarithmic properties. So this was the very beginning of example 4 where we have that half-life. So our final amount is actually, excuse me, I clicked the wrong button. There we go. Our final amount is the initial amount times 1/2 to the power of t over 30, where the 30 represents the time it takes for the half-life to occur. So with your initial amount, it takes 30 years to go from 100 down to 50 or so forth. And we solved this first one at the beginning, determining our initial amount. And it rounded out to be a decimal. And then we said, hey, it would have been, that integer up from there. So using the same problem, same information, now we want to know if the sample starts with 60 grams. So that 60 grams is the initial amount. How long would it take for it to have 45 grams remaining? Okay, so back to our formula. C equals C sub 0 times 1/2 to the power of t over 30. They tell us the initial amount to be 60. They tell us we want to know how long does it take to be 45. So they also tell us that final amount. And then we would substitute that C with 45, and then the remainder of the equation stays the same. So 45 equals 60 multiplied by 1/2 of t, or excuse me, 1/2 to the power of t over 30. The first thing we need to do is simplify to isolate this base so we can get the t out of the exponent. So we're going to divide 45 by 60. We'll divide the other side of the equation by 60 as well. And 45 over 60 simplifies to be 3/4 or 0.75. So in our next part, we're going to write 0.75 equals, I'm also going to change the 1/2 to be a decimal, 0.5 to the power of t over 30. And the reason I'm doing that is so that I'm either working all with decimals or all with fractions. So we're not mixing it up and changing it as we go around. In order to get this out of exponential form, we need to take the log of both sides of the equation. So I'm going to take the log of 0.75 and the log of 0.5 to the power of t over 30. This leaves us with our next step. Remember, when we take the log of both sides, that is log base 10, we can now use our power property to get that power out of the exponent and as a coefficient. So we'll have log of 0.75 equals t over 30 multiplied by log of 0.5. Now we can divide both sides of the equation by log of 0.5. So log of 0.75 divided by log of 0.5 equals t, our time divided by 30. And then to isolate our time all by itself, we would multiply both sides of the equation by 30. So we're going to have 30 multiplied by log of 0.75 divided by log of 0.5. There you go. So let's type that into our calculator. You can put it in just like that. 30 and then the fraction bar, log of 0.75 in the numerator over log of 0.5 in the denominator. Press enter, and it should give you the correct value. Sorry, my calculator froze on me. I had to start all over. Okay, so our time is about 12.45, and this is in years. So just a little over 12.45 years, almost 12 and a half years, you could call it, to go from 60 grams down to 45. So we haven't taken half of it. We didn't go from 60 to 30. So I know it doesn't take 30 years. So it's got to definitely be less than that. All right, next question. If there are 25 grams left after 35 years, what was the initial amount? So now I'm looking for C sub 0. There are 25 grams. That's the final amount of the cesium-137. And they do tell us the time. So our formula, C equals C sub 0 multiplied by 1/2 to the power of t over 30. We can substitute our final amount of 25. That equals the initial amount is what we're looking for, times by 1/2 to the power of 35 over 30. In order to simplify this, you're going to take care of the 1/2 to the power of 35 over 30. And that time is more than 1/2 life, so we should definitely have an amount double of the final. So this simplifies to be 25 equals C sub 0, the initial amount, times or multiplied by 0.445. Okay, in order to isolate to get our initial amount out of, or to get it isolated, excuse me, then we're going to divide both sides by 0.445. So C sub 0 is 25 divided by 0.445, and that gives us 56.179. So approximately 56.2 grams is what we would start with if we want to end with 25 grams of the cesium-137 after 35 years. And one last question for this. Are you tired of the cesium-137 yet? Holy cow. All right, so this time this sample begins with 70. That's my initial amount, 70 grams. After how long, that's the time I'm looking for, do we only have 20 grams remaining? That's our C. C equals C sub 0 multiplied by 1/2 to the power of t over 30. My final amount is 20. That equals the initial amount, 70, multiplied by 1/2 to the power of t over 30. Okay, now I hope you notice that half of 70 is 35. So we've definitely completed at least one full cycle of a half-life. So our time should definitely be over 30. Okay, as we've done in the past, we need to isolate our base with the exponent. So we're going to divide both sides by 70. I'm just going to simplify to give me 2 over 7 equals 1/2 to the power of t over 30. Again, to get rid of an exponential, we have to take the log of both sides. So I'm going to do log base 10 of 2/7 equals log base 10 of 1/2 to the power of t over 30. And our log properties state that that power, t over 30, is going to trickle onto the front and become a coefficient. So log of 2/7 equals t over 30 multiplied by log of 1/2. We are going to divide both sides of the equation by log of 1/2. So I have log of 2/7 divided by log of 1/2 equals t over 30, and multiply both sides of the equation now by 30 so you can isolate the time. So in your calculator, you're going to type 30 multiplied by log of 2/7 divided by log of 1/2, and that should give us our time. Again, it should definitely be over 30 years because we started with 70 grams and we are down to 20 grams. So I'm typing this in, log of 0.5, and let's see what we get. We get our time to be 54.22. So about 54.2 years is how long it takes to go from 70 grams, the initial amount, down to 20 grams. All right, good job with those guys. You now have some time that you can practice some of these on your own. You have a quiz coming up, and again, another one after spring break. Have a great one.